and going from there. Central angle. So when we have a circle, oh, it's on mute, that's why. No wonder.
You have a song for us?
Of course I do. Do I always have a song?
Come on, come on. Let's encourage him.
Do it.
That is the Pac-Man. Oh my gosh. Eat the ghosts, right? Anyone ever play Pac-Man? Come on. Yeah.
I'll be
Right.
What's a Pac-Man?
Just looking at you at this point.
I know, it's just- All right, central angle. Central angle, the central angle is an angle in a circle whose vertex is at the center. Actually, this might not, I might need a little more space than this. Look at this. And sides are radii. Okay. So a central angle is just an angle whose vertex is at the center. Pretty easy to remember that. Hence the word central angle. And the sides of that angle are just made up of the radius. Both sides of that are going to be a radii. Okay. That's pretty much it. The excuse me. The we all know what a semicircle is, right? We talked about this the past couple of days. It's half a circle. What is a semicircle made by? Yeah, the diameter. So a semicircle is half a circle. It's created by a diameter. What's that? Central angle, an angle in a circle, because circle's too many words, whose vertex is at the center and sides are radii.
The plural of radius, which is like a second declension of that noun, is that US ending, and when you make it plural, the US changes to an I, hence the two I's at the end of radii. So.
Nerd!
I'm crying.
You see a lot of that though in your science work.
Yeah, you do.
So that is the
I'm
just science.
dead, bro.
Math is a.
Equal.
Oh, there you go. And that's on our points, and it's Latin.
Nod and smile, put away your phone. Like, away. Thank you. Now, we also talked about this a little bit yesterday. How many degrees does it take you to get around a circle? 360. Because no matter what, if you turn around, you're facing back the same way that you started.
There we go.
All right? Thank you. So there are 360 degrees in a circle, which means then a semicircle takes up half of it. So a semicircle
Will be 180.
correct.
Did you ever do a 180?
Okay. Now, these next two bits are called major and minor arcs. Well, before I do a major and minor arc, I should probably tell you what an arc is. It's not Indiana Jones.
Or we're going ahead.
It's a bad circle.
That's not a good circle.
Shut up. My artwork? My artwork? An arc. An arc. I don't know, if you can't laugh at yourself, whatever. Arc is a section of the circle. I think that's the easiest way to define it. The arc is a section of the circle. It's,
Section of the circle.
I don't want to get there because we're gonna have arc measure, we're gonna have arc length. We're gonna have two different things on that.
Oh, right.
So arc, if I just know that it's part of the arc, could be from here to here.
Okay, so yes.
Yeah, it's part, section of the circle, think of the curve. Think of the curve, maybe? And what we're gonna have is we're gonna have two different measurements of arcs. We're gonna have something called arc measure, and we'll have something called arc length, all right? What we're gonna do between today and maybe a little bit of Monday is what we're gonna talk about is arc measure. Arc measure is the easier of the two, okay? Arc measure is a little bit easier. Arc measure is the degree value. It's not too easy, that right? Yeah, here. I know it seems like there's a lot of definition to start here, but as we start to put it together, bless you, it actually becomes fairly easy. So when we're talking about this thing called arc measure is going to be some degree value, and it's going to be the degree value of whatever your central angle is. Okay? So for example, in the circle here I drew with, I had that arc measure in yellow. If I had a central angle here, those are the sides that created. And if I say that this angle is 65 degrees, what would the arc measure be? The arc measure is the degree value of the arc created by the central angle. So what's this degree? So what's that degree? 65. That's all that is. So what happens here is that you're going to get these arc measures is going to be created by what we call a central angle. Where the angle runs into the arc, it's going to be the exact same angle measurement, same degree value. Okay. If you took a circle, and obviously if you go completely around a circle, if you start at 0, you come back around, you're at 360 then. So depending upon where your angle values are placed, you can measure out angles and stuff like through that. As you get to algebra 2, we still do the same basic idea, but we change it up just ever so slightly. We say this is 0, this is pi, which is 180 degrees, and this is 2 pi, or 360 by going like that. So you have 0, 90, 180, 270, 360. Pi over 2, pi, 3 pi over 2, 2 pi. The reason why we throw pi in there is because, you know, on your calculators, if you accidentally put the thing that says rad, it's
Rad.
because you're all rad, yes. It's called radian value, radian measure. It means you're dealing with in terms of pi. You're looking at proportion of the circumference is basically what that is. Not anything crazy we get into in geometry, but it's algebra 2 is huge. Okay, right now my algebra 2 students, that's all we're dealing with is radian value. As you get into it, it's pretty quick. Right. So we have arc measures. Arc measures made up of what you run into from your central angle. Central angle is the angle at the center, sides of the radii. And then the next two little ones are called what would be a major arc and a minor arc. Think of obtuse or acute angles.
So is it like a minor is like under 90?
It's actually under 180. Yeah. Yep. You're on the right track. So, what? Your point, I thought you had. Oh. So, we look at this, we have what's called a minor arc and a major arc. Okay? We have what are called major and minor arcs. A minor arc is any arc measure that's less than 180 degrees. What's that?
No, 180 is a semicircle.
Yeah, 100. It's going to be less than 180 because if it equals 180, it's the semicircle.
All these are basically like the stuff that we
Exactly. And do you see why I keep bringing that back up? The whole idea of adding angles together, adding segments together, all of that just comes back to this unit. Right triangles, hey, look at that, it's in a circle, and so on. So a minor arc is an arc that measures less than 180. Excuse me. Yes, sir. Oh, give me a second, Caleb. No problem. No worries. When you know how we talked about lettering before? When you talk about angles? Angles you would use, oh, I'm sorry. Angles you would use 3 letters to show it. Angle A, B, C, or whatever would be, B would be at that vertex. When you're dealing with arcs, you're just following the letters on the circle itself. So minor arcs are usually two letters. For example, AB with an arc over it. I know, right? The difference between AB as an arc versus AB as a segment is that AB is an arc. Yes way. And the letters are always, if there's 2 letters, it's always shortest distance between the 2. Because if I say AB, I could theoretically go to the left and loop around. But whenever you're talking about arcs, 2 letters is always meaning it's going to be a minor arc. It's extraordinary. It's pretty rare that they'll use 3 letters for that. Because the difference between that and a major arc is that a major arc is an arc that measures more than it'll be an arc that measures more than 180, but less than 360. Okay, we don't spin, or we don't continually spin around. We do that in algebra 2. We get really dizzy. It's good times. So if I wanted to say that, you usually see that with 3 letters. And the reason why they use 3 letters is because it shows direction. So arc AB would be minor, it's less than 180. Arc ACB goes the other direction, which means it's a longer way around. Does that make sense? That's how that works. That middle letter tells you direction. The middle letter tells you what direction you're going. So if you see 2 letters, always think shortest distance. Boom. 3 letters, it's telling you to go start at your A, and you're going to go to the left of A and loop around. Versus if it was A, B, C, you'd go this way. It's just telling you which way to go. And obviously, you would just follow through on your angles and whatnot. So if I say that this arc here, let's say our central angle is 80. What's my minor arc? 80. What's my major arc? What is it? 280. How? Why do you say it's 280? Exactly. Everybody hear that?
Yeah.
So if 80 is my minor arc, how many degrees are in a circle? 360. So to go the other way around, from here to here, would be 280. That's what we do a lot of in this. And the idea, I heard you say a little bit of, like, it's kind of like working with supplements. Yeah, it is, but sometimes you're working, in this case, a lot of with 360s.
Yeah.
And just going back and forth, okay? Not so bad?
Can I go to sleep now?
No. I mean, it's up to you, whatever, but, you know.
Should have done this on pie day.
What's that?
Little pieces of pie.
Now, when we did angles, if I look at this as, oh, I forgot to put the middle one. If D is the center of this circle, I have angle ADB and BDC. Everybody okay with that? Do those two angles share the same vertex? Yes, they share the same vertex at D. Do they have a common side? Yeah, that BD is the common side. So back in the day, that meant that we can add those two angles together. So the two smaller angles would make a larger angle. Well, now the fact that these two smaller angles are placed inside of a circle, those two angles are central angles, which means what can you do to the two arcs? Add them together, keep them combining. Exactly. It's the exact same thing. Angle addition, segment addition, and dun, 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 arc addition. They're all the same. So in this case, if you wanted to figure out if you have arc AB, I can add those two arcs together because they're all in a row. They all share that same common middle point of point B, if you think of it that way. What would those two arcs add up to equal? 75. Now, when you add those two together, you got 15 plus 60, and it equals 75. Is that a major or a minor arc? It's a minor arc. So could you get away with writing that those two equal arc AC? Yeah. Oops. So these two. It would equal arc AC, which would equal the 75. That's all that is. You can add two arcs together if they're next to each other. Dun, dun, dun. Boy, it looks a whole lot like angles. Which one? Oh, would I do a major arc out of that? Well, you could if I put another one in. Let's say this is E, and this is we'll say that's 100. Can you add all three of those together? Yeah, you'd add all three of those together. You'd have arc AB plus BC plus CE. That would equal a major arc because actually it's technically I need to change that number here. We'll say it's 120 here then. Yes, ma'am.
Couldn't you have done like ACB?
For the one I'm doing right now?
Yeah.
AC.
If you didn't, going around.
Oh, yes. If I went the other direction this way, yes, absolutely. Then if it was ACB, I'm leaving out that 15 degrees, so it would just be 360 subtract the 15. And you'd be at, what is that, 345? Yeah, that's exactly right, Hannah. That's perfect. Okay. But if I continue going around in the way that I'm going this way, my arc would then have to have three letters because it becomes a major arc. So can I write it as A, B, E? Or can I write it as A, C, E? Yeah, they're still going the same direction. Okay, it's just a matter of just following your letters. You just have to pick one of the letters in between. Okay, it's the same idea as we did segments. You didn't have to say, if I put another point in the middle there, it was A, B, C, then D at the end. I could have added all those together and made it work. It wouldn't have been a big deal. Okay? This is really nothing crazy new that you haven't seen before. It's just on a curve. Okay, it's just on a curve. I see what you did there. Congruent angles have, congruent circles have congruent arcs. This doesn't show up very often. It's just something to say. If you have two circles that are congruent to each other, that means that they had to have the same radius. So congruent circles have the same radius. Obviously that makes a lot of sense because if you have one circle that has a radius of 3, any other circle that has a radius of 3 would be the exact same size circle. If one circle had a radius of 3, the other had a radius of 4, that's not the same size circle because 3 doesn't equal correct. It's pretty obvious on these. And then when they say if you have two circles that are the same, that means when you start putting angles, their arcs will measure the same as you go around the circle as you place your angles and stuff. That's it. This becomes more important later. So I wouldn't worry too much about this now. I just wanted to let you know about this whole congruent circle thing. All right. Arc length is a little bit more interesting. Just a smidge, right?
Just a little extra,
Okay. This is the style that you will see then when it comes to problems. It'll give you that whole idea of a big picture problem. It'll give you a little bit of information. Sorry that my handwriting was bad when I wrote this. This is KN. So it tells you that you have circle J, and it's going to ask you to find the following arc measures. Well, they give you one central angle, and they tell you that one of the segments within the circle is a diameter. So if you know that something is a diameter, that creates a what? A semicircle, yeah. So it means on one side of the diameter is 180 degrees, and the other side of the diameter is also 180 degrees. So as you start placing these things in here, see how it works right to supplementary?
No.
Now, you'll figure that out. So what's the supplement of 125? So the supplement of 125 is 55. So now,
I thought you moved to 125.
Oh,
what's that?
supplement.
So now follow your letters. LM, well, what's the arc of LM?
125.
There you go. It's not segment or anything, this would be 125.
That's all you gotta do.
Yeah.
That's nice.
Now LMK. Yeah. Or could you do 360 subtract 55? If you follow the lettering here, it's asking for LMK. So there's going to be a couple of ways you can do it. Like you said, right, you by all means, take the 125, add it to 180, you're going to get the same answer. Or knowing that it's 360 degrees all the way around, you're taking out the wedge of 55. You're going to get the same answer.
That's what I was gonna say. So it's 305.
No, it's like 825.
Hey, there's no ass in math.
All right, so you get 305 on that one. Okay. Go the other direction. KLM. What's that? That's all this is. That's all this is.
But algebra in it.
We will. Of course we will. I gotta start slowly though, because think about it this way: when we did that stuff, we started slow, right? And we slowly put in equations. And we slowly added into the algebra. It's the same process. You start with the basics. You work through the definition. You see how this stuff works. You get comfortable by setting up and knowing how you're adding and subtracting and things like that. And then we'll throw a little bit of algebra at you. Yes, sir. KLM, I started here and I walked around. Isn't that a diameter?
How did you get 180?
So that's 180.
Mr. Murphy, how did you get 180?
Because it's a straight line.
Okay. So again, real fast, there are two ways to get the 305. We are told that Km, ladies and gentlemen, we are told that Km is a diameter, which means this angle here is 180. So if you're following your letters, LMK, it says L past M to K, which meant I'm looking at 125 plus 180. I got 305. Or knowing that all the way around is 360, subtract out the little wedge. There's 2 ways to do it. Alright. I have one more. Last one. Just to add in a little bit more to it. It's an E. You know, I try my best. This is the last example. We'll give you a couple of options. Oh, poor baby. Yes, it is. And then I usually get stop it.
70 plus 50, that's 120. So
I say you'll feel
one
better.
start having 6, C is 180.
It's okay to have fun with your children.
I'm not your children.
I didn't say you were.
That's not how you say it.
I'm not your child.
So again, before you do really anything, what you want to do is you always want to go and see what you can fill in the diagram. Now, if you're looking at this, you've got a couple of the central angles right away, and you're given that you have a diameter. So you know that you have a 50, a 70, a 180. Well, what's left for that middle angle of AED? 60. Good. So you just fill in the blanks. So you know that has to be a 60-degree angle here. So now it's a matter of following the lettering. Remember, 2 letters, shortest distance between 2 points. So if I'm looking at AD, how many degrees is that?
60. That's
70.
70.
Yeah, it looks like 74.
There, it's a 70. Okay. Bless you. AB,
60.
60. CD,
180.
BDC. How much? 310, yeah. 310, because 360. Because you're on B. So you take the 360 and subtract out the 50, and you're at 310.
Next one's 290.
ACD,
290.
290, very good. Going the other direction, you're going all around the circle, subtract out that little wedge in the corner there of the 70, or just add all of them together. You're going to get the same thing, you're going to get 290. And the last one is BC. Arc measures, arc angle, arc. Yes, ma'am. Guys. Is 8 at 110 degrees, are you a major or a minor arc? Minor, so you just use the 2 letters, AC.
If you got your tracks here,
Correct. Because anytime you say 2 letters, you automatically say it's going to be a minor arc, so you just go shortest distance. If you wrote down ADC, it's wrong. It's just, I'm saving you work.
so good. We'll be probably down in your shoulders.
You're welcome.
You come back to my house when you move out. Me and your mama started watching.
There was the footwork. It's the main building in the first year. It was basically Caleb, you came Sorry. All right, so on this one here,
Yes.
Sergeant?
all right, let's do those. Let's do those. I try. Okay. We'll get through those today. Come Monday, we'll add in a little bit more to this. And then that'll give us Tuesday and Wednesday to do arc length, which actually probably won't take that minute. That'll only do arc length. That way, because I'm still planning on quizzing on Thursday. That way we have the buffer day in case anybody's dead on Thursday and take it on Friday. And then we'll do a bunch of construction stuff with this and have our pie off. Pie off, you will be responsible for trying to memorize some digits of pi.
When is that?
Well, it's infinite, so. What's that? I will, hey guys, I will come up with some sort of a sliding scale as far as point values. So if you're able to memorize 30, that might be worth 3 points. You go 50 and so on. We'll do something like that. What's that?
Man, she has great chest, man. Very cute, man. She don't even see. She said, she be. Oh, Dennis.